Okay, this is Math 105 section 5.2. Now we get into talking about the trig functions, the trigonometric functions. We kind of defined them in section 5.1. Now we're actually going to use what we found in 5.1 and define those as the trig functions. So remember we found the terminal point Pxy for a real number t, for a given real number t, where we moved a distance t along the unit circle. Okay, starting at the point 1, 0. So this is the concept we were looking at section 5.1. Counterclockwise if t is positive, and clockwise if t is negative. Okay, so this was we started here, and this, if t is positive, we move this way. If t is negative, we move this way, clockwise. And then where we end up is our terminal point on the unit circle, and that's our Pxy. Okay, now we're going to define the trig functions using those x and y coordinates. So the x and y coordinates of the point Pxy will define our trig functions. So the y-coordinate is called the sine, okay? And the x-coordinate is going to be called the cosine, okay? So the cosine is the x, and the sine is the y, okay? And then the other functions are all defined just using different ratios or reciprocals of the other of sine and cosine. So really we're going to focus our study for this section on sine and cosine, but we're also going to look at tangent, cosecant, secant, and cotangent, but they all come directly from sine and cosine. So you think of that Pxy, what's the input of our function is going to be t, so t is our input, and then we get two outputs, x and y, okay? So x will be the cosine of t, and y will be the sine of t. Okay, so let me write that out. So this is kind of the punchline here. When we get that point, x is going to be the cosine of t. We use that cos, and y is going to be the sine of t. So think of like we have our input is t, and we have two outputs. One is going to be the cosine, which is the x coordinate of the point P, and then one is the sine, which is the y coordinate of the point P. And t is the distance traveled along the unit circle as our input. Okay, so we'll just focus on sine and cosine yet. So t is any real number, okay, and P is the terminal point on the unit circle determined by t, which we determined in section 5.1. And for now, we're just going to say sine of t is y and cosine of t is x. Okay, so we call these circular functions. Okay, so let's do that for now, and then I'll come back and we'll define the other ones later. Actually, on second thought, let's go ahead and show the other ones. So tangent is just y over x. So that's cosine or sine over cosine, right? Okay. Cotangent is x over y, so that's cosine over sine. So that's COT. Okay. Cosecant is 1 over y, which is 1 over sine. Okay, so that's just a reciprocal of sine. And then secant, SCC, is 1 over x. So that's just a reciprocal of cosine. Okay. Now notice that we have to say y cannot be 0 here because we're taking 1 over y, and x can't be 0 here because we're taking 1 over x. And same with this, x can't be 0 for tangent because we have y over x, and y can't be 0 for cotangent because we have x over y. Okay, but notice everything comes from sine and cosine. So once you have sine and cosine, you have the other four. They just follow from there. Okay, so let's look at an example. Let's say we have t equals pi over 3, and we want to find the 6 trig functions. Okay, remember how we did this? We got to pi over 3, and our terminal point was 1/2 square root of 3 over 2 from section 5.1. Okay, so the x would be our cosine of pi over 3, okay, which is 1/2. The sine of pi over 3 would be square root of 3 over 2. Okay, so that would be our starting point there. And there's our terminal point, 1/2 square root of 3 over 2, and here our t is pi over 3. Oh, okay, so continue with A. Since x is 1/2 and y is square root of 3 over 2, the sine of pi over 3 is just the y. The cosine is just the x. The cosecant is 1 over the y, so this is actually 2 over square root of 3, which we're simplifying to 2 times square root of 3 over 3. Okay, so that's just a reciprocal of this one. Now for B, t equals pi over 2. Our terminal point is 0, 1. Okay, we're going quarter of the way up the circle. Right. So we can figure out our trig functions from that. So our sine is going to be the y, which is 1. Okay. Cosine of pi over 2 is going to be the x, which is 0. Cosecant is 1 over sine, so that's 1 over 1, which is 1. Cotangent is x over y, so that's 0, 1. But we can't do tangent or secant because we're dividing by 0, so they're undefined. So we don't have tangent and secant there for pi over 2. So here's a table of trig functions for doing our increments in the first quadrant, starting at 0. Here think of what our x and our y does. Okay, we go 0 to pi over 6, which is a third of the way up, to pi over 4, which is half the way up, the first quadrant. Pi over 3, which is 2/3 of the way up the first quadrant, and pi over 2 is all the way up the first quadrant. Okay, and here's what our numbers do. Now I'm going to show you kind of a trick that we can do with these, and this you can see what the y and the x does. This is the first one is square root of 0 over 2. The second one is square root of 1 over 2. Third one square root of 2 over 2. The fourth one square root of 3 over 2, and the last one square root of 4 over 2. See, that gives us a 1. Okay. Cosine, or x, just does the opposite. It starts at square root of 4 over 2. Then it goes to square root of 3 over 2, then square root of 2 over 2, then square root of 1 over 2, then square root of 0 over 2. Do you see how that trick is? It goes, the y starts at square root of 0 over 2 and then goes square root of 1, square root of 2, square root of 3, and square root of 4 over 2. And then x just does the opposite. It starts at square root of 4 over 2, gives us 1. Then it goes square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2. Okay, if you can remember that, that's all you really need to know for that first quadrant. Because the rest of this is just ratios, right, or reciprocals. Tangent is y over x, sine over cosine. So we're just taking the ratios of these. Okay, you can't take the ratio of this one because it has 0 in the denominator. Okay. So it doesn't exist here. And then cosecant is 1 over sine, so we're taking 1 over this, doesn't exist. 1 over half is 2, etc. We're just taking 1 over sine to get cosecant. Okay. And then for secant, we're taking 1 over cosine. So 1 over 1 is 1. This becomes 2 times square root of 3 over 3. This becomes square root of 2. This becomes 2, undefined. And then cotangent, we're just taking the reciprocal tangent, right? So 1 over 0 is undefined, etc. Okay, 1 over 1 is 1. 1 over square root of 3 is square root of 3 over 3. 1 over undefined, well, that's actually 0. Okay, because you're taking cosine over sine. Okay, so but let's focus our energy on these two. Okay, because everything else just follows from that. So if you focus, and remember we're getting two coordinates from each point, and that gives us the x is the cosine and the y is the sine, right? So once we have those two, everything else just follows along. Okay. Okay, let's talk a little bit about the domains of these functions. Sine and cosine are defined for all values of t. Okay, we're always going to have a sine and cosine. Okay, but things like cotangent and cosecant have y in the denominator. Okay, so they're not defined whenever y coordinate is 0. Okay, for pxy. Okay. So we'll look at, don't worry about this, we'll talk about where that doesn't happen, but we'll skip this stuff for now below. Okay, and also the functions tangent and secant have x in the denominator. So they're not defined whenever x equals 0. Okay, and that happens when t equals pi over 2 plus n pi for any integer n. Okay, and we'll look at where that is undefined, but sine and cosine are defined for all real numbers. Okay, so the domains of the trig functions. Tangent and secant are defined for all real numbers except for pi over 2 plus any multiple of pi. Okay, because that's where you're going to get x is equal to 0. Okay, and then cotangent and cosecant are all real numbers except for any integer times pi, like 1 pi, 2 pi, 3 pi, and that's because you're going to have y as 0, and that's in your denominator. Okay. Okay. Now let's figure out the values of the trig functions, whether they're positive, negative. Okay. So we have to determine their signs. Okay. To get the values of the trig functions. Okay. That depends on the quadrant in which the terminal point lies. Okay. So if our terminal point is in quadrant 3, then coordinates are both negative, which means sine of t is negative, cosine of t is negative, cosecant, which is 1 over sine, and secant of t are all negative. Okay, and then tangent and cotangent are positive because we're taking a ratio of two negatives for tangent and cotangent. Okay, so remember in the third quadrant, x and y are both negative. Okay, so here's how we determine which functions are positive. Quadrant 1, all the trig functions are positive because x and y are both positive. Okay. Quadrant 2, sine and cosecant are positive. I'm just going to highlight sine, okay? Quadrant 3, tangent is positive only because sine and cosine are both negative, okay? And then quadrant 4, cosine is negative, okay? Now I didn't circle the other ones because they sort of follow, like because cosecant is 1 over sine, it's going to be the same sign. Because cotangent is 1 over tangent, it's going to have the same sign as tangent. And because secant is 1 over cosine, it's going to have the same sign. But these are the positive functions. These are the ones that are positive in each quadrant. Everything's positive in 1. Just sine is positive in 2, which means cosecant will be positive. Just tangent's positive in 3 because sine and cosine are both negative. And then just cosine is positive in 4 because sine is negative and that would mean tangent is negative. So that gives us our shortcut. We can write it like this, ASTC, and this tells us the positives. And it's A means all, S means sine, T means tangent, and C means cosine, right? All of them, sine, tangent, cosine. And those are the ones that are positive in each quadrant. This would be our first quadrant, second quadrant, third quadrant, fourth quadrant, right? Let me write that in there. Okay, so this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4, as we know, right? So we're saying all students take calc. So that's how we get this little acronym. All students take calc. If to kind of remember which ones are positive. All students take calc. All sine, tangent, cosine are the positives. Okay, so let's look at some trig functions outside the first quadrant, like cosine of 2 pi over 3. So remember that 2 pi over 3 takes us 2/3 of the way around the half circle, which means our reference number, remember this is our t, okay, we're going positive, so we go counterclockwise. Our reference number, t bar, is pi over 3. So we're going to use the numbers from pi over 3, okay? And remember, pi over 3 gives us, I'll write these out, t equals pi over 3 gives us the terminal point 1/2 square root of 3 over 2, okay? So we're going to use those as our reference to our, we're going to use those numbers, but we have to figure out the sign of them, okay? So remember, cosine of 2 pi over 3, think of where the x is. The x is negative, right, because we're in the second quadrant. All students take calc, this will be our s, so just the sign is positive, which means the cosine is negative, which means we're going to grab this half from the pi over 3, which is the x, but change the sign to -1/2, okay? So there's our cosine of 2 pi over 3 is -1/2, because it's the opposite of cosine of pi over 3. And similarly, we could say that the sine of 2 pi over 3 is going to be square root of 3 over 2, which is the y here, but the y doesn't change, right? We're still positive y, so we could just use the positive there. Okay, so the sine of 2 pi over 3 is going to be that square root of 3 over 2. Okay, now let's look at tangent of minus pi over 3. Okay, we can see as we go negative, we're going to go from this point 0, 1 to the clockwise to pi over 3. So we go to 1/3 of the way across the half circle backwards. Okay, our reference number is t bar is pi over 3. So we're going to use the numbers from pi over 3. But one of them is going to be negative in this case. In this case, the y will be negative. So we're going to have minus here and a plus here. Okay, so what we're doing is we're taking sine over cosine, right? Okay, so we can do this. The sine of minus pi over 3 over cosine of minus pi over 3 to get the tangent. This is kind of the other way to do it. So that's going to give us, now remember the sign is negative, so that's minus square root of 3 over 2 divided by a plus 1/2. Okay, and I'm pulling these numbers from here. I'm saying, okay, the y is square root of 3 over 2, for pi over 3 up here, but we're going to minus y. Okay, so it's minus square root of 3 over 2. The half is the same because the x doesn't change. Okay, so minus square root of 3 over 2 divided by 1/2, and that just gives us the minus square root of 3 there. So that would give us our tangent of minus pi over 3. Okay. Okay, now let's look at the sine of 19 pi over 4. Okay, that's what we're looking at for our last example. Now, that's more than one circle, right? In fact, that's 4 circles plus 3 pi over 4. So we can take out, sorry, it's 2 circles. So we can take out 4 pi, okay, which is 2 circles, right? Because 4 pi is 16 pi over 4, right? pi is 4 pi over 4, so 4 pi would be 16 pi over 4. So that's two circles. So we subtract two circles because they're redundant. That doesn't change anything. So we take 19 pi over 4 minus 16 pi over 4, which is 4 pi, and that gives us 3 pi over 4. So we can just use 3 pi over 4 as our angle, now as our t. Now think about what the t does, right? This is 8 pi over 4, 16 pi over 4, I'm going to the circle twice now, and then another 3 pi over 4 will give me 19 pi over 4. So that takes us here. And we went on the circle twice, and then we went 3/4 of the way around the half circle. Now so there's our t, 19 pi over 4, or we can say 3 pi over 4, because we can just do this, right, instead of going around the circle twice. And then our reference number is going to be t bar equals pi over 4. Okay, so there's our reference number. And remember, for t equals pi over 4, our terminal point is square root of 2 over 2, square root of 2 over 2. Okay? And we want to look at the sign. So we're going to look at the y. Okay. But the y doesn't change. The y is still positive. So that would just be square root of 2 over 2. Okay. So the sign of 19 pi over 4 would just be just the y there. Square root of 2 over 2. The sign does not change, right? Because it's positive. Y is positive there. Okay, so just to summarize, sine of 19 pi over 4 is the same as sine of 3 pi over 4 because we took away two circles. And that's the same as sine of pi over 4 because the y is the same. So it's square root of 2 over 2. Okay, and generally in a scientific calculator, you will have sine, cosine, and tangent as functions. Okay. In the case that we're doing now in Chapter 5, we have to be in radian mode because we're actually we're using the angle in radians right now when we do that t. Okay, that distance around the unit circle is actually the measure of an angle in radians. Okay, so we have to be in radian mode. And you'll probably see a DRG button, something like this. DRG, okay. And that toggle, that's a three-way toggle, and it's toggling between degrees, radians, and gradients. We're not going to use gradients for this course, but we're going to use degrees in Chapter 6, so it'll go between degrees, radians, and gradients. We want to be in R in radian mode. Usually it'll say RAD or something like that in your calculator. Okay. Now, when we're trying to find the other trig functions, we have to use the reciprocal identities. So remember, cosecant is 1 over sine, right? Secant is 1 over cosine. And cotangent is 1 over tangent. So to find these, we're going to use our reciprocal relations in a calculator because generally you only have the three, the sine, cosine, and tangent in your calculator. So if you want to find cosecant, secant, and cotangent, just take the reciprocals of sine, cosine, and tangent respectively. Okay, and here's some just examples of using a calculator. Now make sure we're in radian mode because we're not using degrees here yet. Okay, so we're in radian mode. Sine of 2.2 is approximately 0.808496. Cosine of 1.1, again radians, is about 0.453596. Cotangent of 28 would be 1 over tangent of 28, so we would take tangent of 28 and take the reciprocal in our calculator, which is about minus 3.553286. Cosecant is 1 over sine, so 0.98 radians, 1 over sine of 0.98 radians, 1 over that would be 1.204098. Okay. So again, we're using, these look like degrees, but we're not using degrees yet. We're using radians still. Okay. Okay, now let's compare our basic trig functions when we take a negative angle. Look at sine of minus t. So here's t, right? Minus t would take us down here. Now notice what changes. The x doesn't change, okay? So the cosine of minus t will be the same as the cosine of plus t, okay? If we go minus t, we still get the same x. What changes is the y, right? So the sine of minus t is going to be minus sine of t, okay? Now if you remember, we look at the graphs. If you remember this happening, this is an even function, cosine, okay? Symmetry about the y-axis. And this is an odd function, which is symmetry about the origin. But we'll get into that when we look at graphs in section 5.3. And then because tangent is y over x, or sine over cosine, y changes sign, but x doesn't. So this means tangent of minus t would be minus tangent of t, okay? So we can see that tangent is also an odd function. So sine of minus t is minus sine of t. Cosine of minus t is cosine of t. Doesn't change. Tangent of minus t is minus tangent of t. So we can see that sine and tangent are odd, and cosine is an even function. Okay. And remember, odd means symmetry about the origin, and even means symmetry about the y-axis. So when we look at the graphs, we'll see that. Okay, and because sine is odd, So is cosecant because it's a reciprocal sign. So if we say reciprocal of an even function is even, and the reciprocal of an odd function is odd, it doesn't change that. Okay, cosine is even, right? Cosine of minus t is plus cosine of t. So secant is also even because that's 1 over cosine. Tangent is odd. Tangent of minus t is minus tangent of t. So cotangent is odd because that's a reciprocal. Okay, so those are the even odd properties. Okay, so let's look at a couple examples using our even odd properties. Sine of minus pi over 6. We know sine is odd, so sine of minus pi over 6 is minus sine of pi over 6. And we know sine of pi over 6 is 1/2. Okay, so that would just be minus 1/2. Cosine is an even function, so cosine of minus pi over 4 is cosine of plus pi over 4, which is square root of 2 over 2. Okay, so that one doesn't change. Okay, let's talk about our fundamental trigonometric identities, trig identities. Okay, so we already looked at our reciprocal identities, right? Cosecant is 1 over sine. Okay, secant is 1 over cosine. Cotangent is 1 over tangent. Tangent is sine over cosine. And cotangent is cosine over sine because it's a reciprocal of tangent. Okay, but we did not talk about these yet. Pythagorean identities. Okay, sine squared plus cosine squared equals t. Now that's the most important one, and that comes from, remember we're talking about sine being the y, right? Y squared plus x squared is cosine equals 1. Remember, that's just the equation of our circle, unit circle, right? So that comes directly from the equation of our unit circle. Sine is y, cosine is x, so y squared plus x squared equals 1. Okay, so it follows that sine squared plus cosine squared is 1. Okay, we also have a couple others, and these are just based on this basic Pythagorean identity, the one that sine squared plus cosine squared equals 1. That's tangent squared plus 1 equals secant squared. Okay, that just comes from dividing both sides of the equation by cosine squared. Okay, so if we divide both sides of this by cosine squared, we get this identity. Okay, and if we divide both sides of this by sine squared, we get 1 plus cotangent squared equals cosecant squared. Okay, so these all come from this sine squared plus cosine squared equals 1. Okay, the other two. So that, again, we have tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared. You can kind of think of it this way. Tangent and the non-cofunctions go together, tangent and secant. Tangent squared plus 1 is secant. And then the cos go together. Cotangent squared plus 1 is cosecant squared. Okay, but they're easily derived from this equation, both of those. So these are important because we can use them to relate any trigonometric function to any other. So if we know the value of any one of the trig functions at t, then we can find the values of all the others at t. So we only need one trig function to find the others, basically. So for example, let's say we know our cosine of t is 3/5 and t is in quadrant 4. Okay, that would mean our sine would be negative, right? But we can use our Pythagorean identity. We could say sine squared plus cosine squared is 1, right? So sine squared plus 3/5 squared is 1. Cosine is 3/5. So that 3/5 squared is 9/25. So sine squared plus 9/25 is 1. Subtract 9/25 on both sides, we get sine squared equals 1 minus 9/25, which gives us 16/25. And then we can say, take the square root of both sides. So that's what we're doing. Our next step is taking the square root of this equals the square root of this, but we got to do plus or minus, right? So that's how we get sine of t equals plus or minus 4/5, because square root of 16 over 25 is 4/5. Okay, we have to figure out which one to use, though. Okay, because we're in quadrant 4, our sign will be negative, right? Because the y is negative, so we're going to use the negative. So sine of t would be minus 4/5. Okay, so our sine of t is minus 4/5. Okay, so we got cosine of t is 3/5, sine of t is minus 4/5. We can figure out the rest because they're all related to these, right? Tangent is sine over cosine, so we have minus 4/3, minus 4/5 over 3/5. Cosecant is 1 over sine, so that's minus 5/4. Secant is 1 over cosine, so that's 5/3. And cotangent is 1 over tangent, so that's minus 3/4. Okay, so once we find the cosine and sine, the rest are easy to find. Okay, one thing to note though, when you do these 6 trig functions, if you have a square root in your denominator, let's say we have this. For example, let's say we have cosine of t equals square root of 3 over 2, which means we're looking, let's say for t equals pi over 6. Okay, right? Just as an example, not this one that we just looked at. So secant of t is the reciprocal of that, right? I'll put that t in parentheses. So that's 2 over square root of 3, right? But we've got to rationalize our denominator, so we've got to multiply times square root of 3 over square root of 3. It's important that we do that for these trig functions, that we rationalize. So 2 times the square root of 3 over 3 would be our answer there. Okay? So you got to rationalize your denominator when you have square roots in the denominator. Okay. We'll look at some more detailed examples of this in class and kind of go over what we're talking about when we say angle and radians, which we haven't really talked about in this video lecture explicitly, but the idea is that your distance traveled on the unit circle is a measure of your angle and radians. It's the same thing.